In this video, we will learn the definition of sigma algebra and we will also learn some example. Okay. So, we normally define sigma algebra for a non-empty set, and for a non-empty set X, sigma algebra is just collection of subset of that set X which will satisfy some property. Now, what properties that need to satisfy, we are going to list that. So, suppose let X is a non-empty set, X be a non-empty set. Now a collection this collection is denoted by the Greek letter sigma. Okay, this is sigma and this is S. In Greek letter this is sigma, but in English this is S corresponding. So here is S, that's why it denoted by sigma symbol. Of subsets of the set X is called an sigma algebra. This is capital letter, this is small letter, sigma algebra. This is capital sigma, this is small sigma in Greek letter on X if it has the following properties. If it has the following properties. So what are the properties? The first property is the empty set and the whole set would be in sigma in that collection. Okay, empty set and the whole set would be in that collection. Second property is if there is subset A which is in that collection sigma, then its complement, that means AC, would be also in that collection. Okay. So if there is a set, then its complement would be also in that collection. And third property is if A1, A2, there are infinite number of subsets which are in sigma, then their union, so I equals to 1 to infinity, would be also in sigma. So if there are infinite collection of subset, then their union also would be in sigma. And the pair, the set X and sigma is called a measurable space. When we define probability, we normally need sigma algebra. Okay, because in probability we define events, and for probability is 1, whole probability is 1. So in that case we normally need this sigma algebra. So we can now discuss some examples. So to discuss examples, we need a set X. So let X is 1, 2, 3, it has 3 elements. Then first number sigma equals to, if we consider this collection empty set first, then X, then element 1 and then element 2, 3, then this is a sigma algebra. is a sigma algebra on X. Why this is sigma algebra? Because it satisfies the first property, empty set and the whole set in that collection. Now in second property, if A is in that collection, their complement would be also in that collection. So here the empty set, its complement is X, its complement is empty set 1, its complement is 2 3, its complement is 1. So for any element, its complement also in that collection. Now for third property, the union should be in that collection. So if you consider empty set and X, their union is X, the whole set. And if you consider 1 and 2 3, so their union is X. If you consider empty set and 1, their union is 1, that is also here. Okay, so it satisfies third property. So this collection is called an sigma algebra. Now we can give second example. If we consider sigma equals to empty set X, then 2 1 3, this is also a sigma algebra on X. This is similar as first one. Okay, how about this one? If we consider sigma equals to empty set X, then 2, then 1 2 and 2 3. So is it a sigma algebra? Let's check. It satisfies the first property because empty set and whole set is in this collection. Now if 2 is in this collection, then its complement should be in that collection. So complement of 2 is 1 3, right? Complement of 2 is 1 3. Is it here? No, the 1 3 element is not here. So this is not a sigma algebra because it doesn't satisfy the second property. Okay, if it doesn't satisfy the second property, you do not need to check the third property. Okay, because to be a sigma algebra, it needs to satisfy all of the three properties. So this is not a sigma algebra on X. Now if we consider this one, the empty set and X, this is also sigma algebra. This is a trivial sigma algebra because it satisfies the first property. It also satisfies second property because the complement of empty set is X, the complement of X is empty set. It also satisfies third property because the union is X, the whole set. So this is also a sigma algebra. Is a sigma algebra on X. Also the power set is this one, the power set of X. The power set of X is empty set X, then element 1, then element 2, element 3, then element 1 2, 1 3, and finally 2 3. Since this has 3 elements, so it should have 2 to the power 3, that means 8 subset 1 2 3 4 5 6 7 8. So we include all of the subset. So this is also a sigma algebra. So that's it for sigma algebra. Thanks for watching.